Hello, good day. Back again on the principle of mathematical induction. So if we look at our previous video, we've made some steps on how to resolve problems that are based on mathematical induction. Okay. Now here before us on the board we have two questions. I see prove the following by induction. 3 plus 5 plus dot 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 plus open bracket n square minus 1 is equals to 1 over 6 n open bracket n minus 1 close bracket n close bracket 2n plus 5. Okay, that is one question. The other one is you can see this is a sum of a geometric progression whose the common ratio is less than 1. So we have a plus a arrow plus a dot 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 plus a arrow raised by n minus 1 is equal to a open bracket 1 minus arrow raised by n all over 1 minus arrow. So we're going to do that very quickly. Okay, and you recall that in proof by induction, the procedure, the first thing is you have to do is to show, or what you intend to prove, you must show that it is true when n is either 1 or 2. Okay, so once that is shown, the next step is since it is true for n is equal to 1, you then now assume it is also true for n equals k. Okay, that is the second step. And once you are able to establish that, the next step is for you to see to show that it is also true for n is equal to k plus 1. So these are just the procedure, but these procedures you have to follow them tenaciously. So you have to do them bit by bit so that you are able to arrive at the answer. Okay. Now let's take a look at the first one. The first one we have on our left hand side. I want to show that when n is 1, n is equal to 1, we want to show that the left hand side and the right hand side, they are equal. So on the right hand side, on the left hand side here we have a n square minus 1, and on the right hand side we have 1 over 6 n into n minus 1 open bracket 2n plus 5. So we will show that it is true in this case. Okay, here n square means if we substitute n equals to 1, we have a 1 square here minus 1. Here we have 1 over 6 into 1, then 1 minus 1. Here we have a 2 times 1 plus 5. Okay, very quickly, 1 square is 1, and then 1 minus 1 here. On the left hand side we have 0 here. Okay, if we look at our right hand side here, this 1 minus 1 here has already killed everything there. 1 minus 1 is 0, so and 0 multiply everything here, it become 0. So here we have been able to establish that what we are trying to prove is true when n is equal to 1. Both sides are the same. So once we have established that, we cannot go further to say that since it is true for n is equals to 1, that means it is also true, it also holds for n is equals to k. So that is the next step. We see n is equals to k. So n is equals to what? K. So what we do here, we rightly substitute. In place of n, we put k on both sides of the equation. So here it becomes 3 plus 5 plus dot 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 plus, here will become k squared minus 1 is equals to 1 over 6 k, then k minus 1, you close the bracket, open bracket, 2k plus 5. So we have established that, we've done that, and the next step is for us to assume, or for us to show clearly that n is equals to k plus 1. N is equals to k plus 1. So this is what we are going to do. But before then, like I said, what you need to do here, you look at which function is generating this sequence. Okay? So the function that is generating it is n squared minus 1. N squared minus 1. Okay? So in place of n here, you put k plus 1 in this n squared minus 1. So in this place, this is, we have n squared minus 1. So here what we need to do, we are going to replace wherever we see n in this place, we'll replace it with k plus 1. So here this become this is k plus 1 or square. You know we have a minus 1 here. So first, then that's what we do here. So let us now open this bracket. We need to open it, and if we open this bracket, this become, we are saying k plus 1 bracket k plus 1, you know, minus this one here. So k times k, we have a k squared. K times 1, we have a plus k. 1 times k, we have a plus k. 1 times 1, we have a 1. K minus this one that was there before. And you see that 1 minus 1 will be off, and who will be left? This expression becomes k squared plus 2k. Is that clear? So what we have just done here is that we put n is equal to k plus 1 in this place, and the result is this. So we know we have to take note of this result. So this particular result that that comes from this expression, we add it to both sides of the equation. So we're going to add it to both sides of the equation. Okay? So here we can now come that here is, we see add, so take note, add k squared plus 2k to both sides of equation, okay, of the equation. So add k squared plus 2k to both sides of the equation. So that's the next thing we will do. And our equation here is, we have a 3 plus 5 plus k squared minus 1 plus this quantity here, the same, k squared plus 2k is equals to 1 over 6, okay, open bracket, k minus 1, open bracket, 2k 5 plus this term, k squared plus 2k. Okay, so we've done that. We add this term to both sides. What you need to do here is to concentrate on the right hand side. So let's come to the right hand side and see what we have here. We have a 1 over 6, 1 over 6k, open bracket, k minus 1, and a close bracket, open bracket, 2k plus 5 plus 2k square plus k square plus 2. Okay, now we need to simplify. This. Okay, so here this is over 1. So the LCM of this fraction is 6. The LCM of the fraction is 6. Here, 6 divided by 6 is 1. 1 times this, the whole of this 10 becomes this place. This time this becomes k square minus k. Here we have a 2k plus 5. Here. Then here 6 divided by 1 is 6. 6 times everything in this place become plus 6k square plus 12k. Okay, so we see simplify further. We open this bracket. This quantity here, this one will multiply this. It will also multiply this. While this k will multiply this as well. It will also multiply this. So if we do that, carefully, you see that k square times 2k, that one will give us 2k cubed. Okay, k square times 5 will give us plus 5k square. Okay, then minus k times 2k will give us minus 2k square. Okay, minus k times plus 5 will give us minus 10k. That will give us minus 5k. Plus the terms we have here, 6k square plus 12k plus 12k. Please, I just have to manage plus 12k plus 12k over 6. So we will collect terms that are related. Those one with I will start with this. We have a 2k raised to 3, 5k square minus 2k square. That will give us 3k square plus 6k square. That will give us 9k square. Here we have minus 5k plus 12k. That will give us plus 7k. Everything over 6. Okay, so here we can see that something is common. We have k in all of them. So we can factor it out. We can factor 1k out. Let's say k open bracket. This is what, 2k square plus 9k plus 7. Okay. Okay. So we have that. Everything over 6. Everything over 6. So we can also factorize further. So see, this time this will give us 2k square times 7 will give us 14k square. Okay, if we are looking for two numbers that can be added to give us 9, at the same time if we multiply it, the two numbers will give us 14k square. It's just 7k plus 2k. Okay, alright, so if we do that, so that means if we factorize this, it will become k. Here we have what is inside is 2k square plus 7k plus 2k plus 7. So we can factorize. So if we factorize this, well, everything is remember is over 6. It's over 6. Okay? By the time we do the simple factorization, you will now see that here k will be at, we have 2k plus 7. Here we see plus 1. Here we have 2k plus 7 as well. So if we factorize this, what we are going to have here is going to be k open bracket k plus 1 close bracket here open bracket again. Here will be what 2k plus 7 over 6. So the quantity on the right hand side is the whole of this, and what we have here on this side, look at the quantity we have here. The quantity we have here, we can simplify it as this one is k squared minus 1 plus k squared plus 2k. So if we aggregate it, this will give us 2k squared minus plus 2k minus 1. Is that clear? So this is the right hand side, and here comes the left hand side. So let's do that. Let's substitute 1 when k is 1 here. We substitute when k is 1 here. This is 2 open bracket 1 square plus 2 bracket 1 minus 1. 2 times 1 square. 1 square is 1. 2 times 1 is 1 plus 2 here. 2 plus 2, 4. 4 minus 1. So we have gotten 3 on this side, on the left hand side. So let's come to this place. Let's put here, we have a k open bracket k plus 1 and 2k plus 1. So let's substitute 1 in place of k. So if we put 1 here, we will have 1 open bracket 1 here, that is 1 plus 1, that will give us 2. Here 2 times 1 is 2 plus 7, that gives 9. So if we do this, everything over 6. So 2 divided by 2, 1. 2 divided by 6, that will give us 3. 3 here, 1. 3 in 9 is 3. You see that they are both sides. This one is 3. The left hand side is 3, and the right hand side is 3. This shows that we have been able to show that by induction that for n is equal to k plus 1, and our proof ends there. Then let's look at the other question. So let's prove the other question. The other question says that is number 2. Say this, we have a plus a arrow raised by n minus 1 is equals to a open bracket 1 minus r raised power n all over 1 minus r. Okay, I think that's the question. So that's the second question. So quickly we look at that. Like what we said, the first thing we have to do here is to see that both sides are the same if n is equal to 1. So let's do that. Here we have n is equal to 1. So here we have a 1 minus 1. Okay. Here we have a open bracket 1 minus r raised to 1. That is just 1, 2. All over 1 minus r. You know, 1 minus 1 is 0. So any number raised to 0 here is 1. So this side is a. If you look at this side, this 1 minus r will go 1 minus r. So both sides are what? They are the same. So we have proved that, we have shown that. Okay? Since we have been able to establish that fact, then let's quickly move to n is equal to k. N is equal to what? Okay, and if we do that, this become n is equals to k. So we have a plus a arrow, a raised to power arrow, k minus 1 is equals to a open bracket 1 minus arrow raised to power k close bracket 1 minus arrow. Okay, we are able to establish that. Now that we have done that, the next step is to say we are looking for kn is equals to k plus 1. N is equals to k plus 1. That's what we will now establish. So whenever we see n, we put k plus 1 there. So we come here. Let's come here now. We say this is this becomes a r raised power. This one will now be k plus 1. You know there's 1 minus 1 here before, and everything here will now be reduced to a raised to power k. So it is this a arrow raised to power k that we needed to be added to both sides of the equation. So we have to take note of that. So we do the next thing, we say add a arrow raised to power k to both sides of the equation. Okay, so we do that. We come here. This is a plus a arrow plus dot plus a raised to power k minus 1, which is there before, plus this term a arrow raised to power k. So on the right hand side we have a bracket 1 minus arrow raised to power k close bracket all over 1 minus arrow plus this same quantity here a arrow raised to power what? K. Like I told you, once you are here, just concentrate on the right hand side. You simplify here. Once you are done with this, we are almost there. So let's look at this. If you look at it, this is means over 1. So the LCM of that particular fraction is 1 minus, of this expression is 1 minus r. So 1 minus r divided 1 minus r is 1. So use the 1 to multiply this quantity. So we have here a open bracket 1 minus r raised to power k. So here 1 minus r divide this, it will give you this term 1 minus r. Then 1 minus r times this will become plus a raised to power k bracket 1 minus r. So here we have to be careful so that we will not make a mistake. Okay? Quickly. Now let's look at this. We have a this place. We have this is equal to, in this term we have a minus a arrow raised to power k plus here we also have this time this we have a arrow raised to power k here. Then here we have a minus a arrow raised to power k plus 1. So here let me demonstrate here. This place is a arrow raised to power k times arrow raised to power, there's 1 here. So from indices, this arrow and this arrow, they are the same base. So we need to add the power. That's why this one become arrow raised to power k plus 1. Okay? I hope we've clearly understood that. That's why this one didn't. You know, everything is over 1 minus arrow. Okay. Now if you look at this minus a arrow raised to power k plus minus a arrow raised to power k, they are off completely. They are what? Off completely. And we are now left with A. We're left with A minus A arrow raised power K plus 1 over 1 minus R. So we can also simplify further. We can simplify further that this is A bracket 1 minus arrow raised power K plus 1 all over 1 minus R. So this is our right hand side. Okay, the left hand side is 6. Okay, this is the left hand side and the right hand side. Let me bring them together here. Here we have a arrow raised power K minus 1 plus A arrow raised power K. So here we have A open bracket 1 minus arrow raised power K plus 1 close bracket, then 1 minus R. 1 minus R. 1 minus R. So we will try to see whether they are both equal if we put K equals 1. So if we assume that our K is 1. So if we put it here, this becomes A arrow raised to power 1 minus 1 plus A arrow raised to power 1 is equals to, this is A open bracket 1 minus arrow raised to power, this is 1 plus 1 close your bracket all over 1 minus R. Okay, here 1 minus 1 is 0. That means arrow raised to power 0 is 1 from indices is equals to 1. So here we just have A plus A arrow. Okay, here let's come to this other side. This is A plus A arrow. Here we have A open bracket 1 minus R square all over 1 minus R. Okay, we can see clearly there. Here we factor out the A. We have A here. This is 1 plus R on the left hand side. Now if you see what we have here, we have 1 minus R square. And we have here 1 minus R. Now if you recall, let me put it here. If we recall that if we have A square minus B square is the same thing as A minus B open bracket A plus B. So we are using difference of 2 square with this 1 minus R square is the same thing as 1 minus R open bracket 1 plus R. The application of algebra. So difference of what? 2 square. Recall this one here can also be 1 square. Okay. So by then we will replace 1 minus R square with this, with 1 minus R open bracket 1 plus 1 R. Okay. So here on this side we can now boldly write that this is A open bracket 1 plus R is equals to A open bracket 1 minus R plus bracket open bracket 1 plus R all over 1 minus R. Okay? Then you can see that this 1 minus R at the numerator and 1 at the denominator cannot go off. And you see, it becomes very obvious that the left hand side and the right hand side, they are the same, because the term here is A open bracket 1 plus R, and the term here is also A bracket 1 plus R. So we are able to prove by induction that the sum of a geometric progression is equals to A open bracket 1 minus R raised by n close bracket all over 1 minus R. So this is how far we can go on mathematical deductions. Once you are able, to follow the steps involved, in a piecemeal, bit by bit, there's no way you will miss this. So the recap: first thing you must show that what you are trying to find out is true for n is equal to 1. Once you are able to establish that, the next thing is you must also assume, since it's true for n equals 1, you must also assume that it's also true for n equals to k. Then before you now go further to assume that it is true for n is equals to k plus 1, then you will carry out your operations. Please do help me to subscribe and also share to other platforms. Thank you very much, and I'm still coming with more videos on mathematics. Have a nice time.